Before you take the second quiz for Chapter 8, let's just have a quick recap of quadratic expressions and quadratic equations and quadratic functions and the parabolas that they describe. Let's look at this quadratic expression right here. First of all, we know it's a quadratic because it includes an x squared term. Quadratic expression may or may not also include an x term, x to the first power, and an x to the 0th power, or just a constant term at the end. And this is arranged conveniently for us in descending order. We like to see things arranged in descending order because then we can look at the leading coefficient and call that a. And in this case, that leading coefficient is just 1. The coefficient on the x term then we call b, which is 8 in this situation, and the constant at the end we call c. In this case, c equals 16. Now, when this quadratic expression is used in an equation and set equal to some value, for example 0, we're often asked to solve the equation and find the values for x that make this equation true, so that x squared plus 8x plus 16 does in fact equal 0. And we can find those values for x either by factoring, or by using the AC method, or by plugging a, b, and c into the quadratic formula. The quadratic formula, as you know, is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. If instead of asking you to simply find the solutions when we set this expression equal to 0, you're asked to actually graph this equation so that, say we have y equals x squared plus 8x plus 16. We can easily plot this up in the usual way by making a little table with 2 columns, one for x and one for y, and just choose some values for x, say -1, -2, 0, 1, 2, etc. Plug those values into the equation for x and find out the corresponding value for y, then plot all those points on the xy coordinate system. We'll find that this equation, this function here, describes a parabola when you graph it on the xy plane. So if we have a word about parabolas here, the shape of a parabola is approximately like this. It's symmetrical, so you can fold it in half and one side will exactly overlap the other side. It has a vertex, and it either opens upward or downward. And the parabola can be shifted up or down depending on the values of a, b, and c. This parabola could be shifted up or down. Maybe it's over here, like this, in which case the vertex is up here. And this is the axis of symmetry where you can fold it in half. Or it could open downward like this, and that's the vertex. In this situation, the parabola never crosses the x-axis. In this situation, the parabola also never crosses the x-axis. All of the y values are positive. Over here, all the y values are negative. With our first parabola, the vertex is exactly at the origin. So there's only one place where it crosses the x-axis. Same for this parabola right here. There's only one place where it just touches the x-axis before it changes direction and goes back up. Now, we can also have a parabola that looks like this. Now the vertex is up here where it changes direction, but there are two locations where it crosses the x-axis. But however many times it crosses the x-axis, it's either going to be 2 times, 1 time, or no times. Wherever the parabola might be in the xy plane, it's always going to cross the y-axis somewhere. And it's only going to cross the y-axis once. It will never cross the y-axis more than once. So when we are asked to graph a parabola or a quadratic function, usually what they want us to do is find the vertex, find the x-intercepts, the places where it crosses the x-axis, find the y-intercept where it crosses the y-axis, and notice whether it opens up or down, and note the axis of symmetry. We can easily find all of that just by looking at this equation. So in this case, a equals 1, that's the coefficient on the x squared, b equals 8, and c equals 16. For the vertex, the x-coordinate is just equal to negative b all over 2a. In this case, that is negative 8 over 2 times 1, which is negative 4. The y-coordinate, then, is whatever you get when you take negative 4 and plug it into the original equation. So let's do it. Y equals negative 4 squared plus 8 times negative 4 plus 16, which would be 16 minus 32 plus 16, and that equals 0. So the vertex of our parabola is just located at the coordinate x equals negative 4, y equals 0. So this coordinate tells us some interesting things about this parabola right away. First of all, note that it's at y equals 0. So at y equals 0, the parabola changes direction. So it's just going to touch the x-axis at y equals 0, and then it's going to change direction. This means that there's only going to be one x-intercept. We can also note that because the leading coefficient on the x squared term is greater than 0, the parabola opens upward. So the parabola is going to come down, just touch the x-axis at x equals negative 4, then it's going to reverse direction and go back up again. So if we plot this up, negative 1, negative 2, negative 3, negative 4, right at y equals 0, that's going to be the vertex. The axis of symmetry then for this parabola is going to be right there. So the parabola is going to go in that direction, upward. And it's going to be symmetrical around this line. And that line is simply the axis of symmetry is at x equals negative 4. Whatever the x-coordinate of the vertex is, that tells you the equation for the axis of symmetry. Let's find the y-intercept. We do that by setting x equal to 0, so it's going to intersect somewhere here on the y-axis, and at that point x equals 0, so we'll have y equals 0 squared plus 8 times 0 plus 16, and that just equals 16. So way up here at y equals 16, so that is where this is going to hit the y-axis here. It's not going below the x-axis, just grazing and going back up in this direction. It's actually going to look something like this. Let's clean that up a little bit. So with that, we've done everything that we were asked to do. We found the vertex. We found the single x-intercept right here at the x-axis. We found the single y-intercept over here at y equals 16. And we made a note of the axis of symmetry at x equals -4.